Okay, so welcome again. And in this video, we're going to look at the following problem. So let P, Q, and R be the following propositions. P is the proposition that you get an A on the final exam. Q is the proposition you do every exercise in this book. And R is the proposition that you get an A in this class. So I've got three propositions over here, P, Q, and R. And the question states here, write these propositions, write the following compound propositions from A to F using P, Q, and R and any set of logical connectives that may be appropriate. So let's take the first one here. You get an A in this class. Okay, so this piece over here, you get an A in this class, which is being held by P. So this piece over here is P. But you do not get every exercise in this book. So Q is a proposition that you do every exercise in this book. So you do not do every exercise in this book. Well, this becomes in this case not Q. Okay. Now when you see the word let's see, you get an A in this class. You get an A in this class. Okay, there's a slight typo that this P is actually R. Okay, so when you see the word but over here, it actually is also logically equal to saying and. Okay, so you can read this as you get an A in this class and you do not do every exercise in this book. So I can write A as R and not Q. Okay, let's look at part B here. Part B is you get an A on the final. You get an A on the final. You do every exercise in this book and you get an A in this class. So you get an A on the final, you get an A on the final, which is P. So you have P and you do every exercise in this book. Excuse me. You do every exercise in this book, which is Q, and you get an A in this class, which is R. So this piece over here is for part B. Part C. To get an A in this class, it is necessary for you to get an A on the final. So let's think about this. To get an A in this class, it is necessary for you to get an A on the final. Okay, so to get an A in this class is being done by the propositional variable R. Okay, so I've got R, and then I've got, for you to get an A on the final, get an A in this class is P. Okay, so I need to get something between R and P here. Okay, so if R, then P. Okay, so this implies that as long as R happens, which is you get an A in this class. Okay, if you get an A in this class, if that holds here, the validity of the statement, if R then P, in order for this to be true, the conclusion P must actually also be true. Okay, so this big box over here, the big box in purple, for this to be 1, for this to be actually true, right? What are the possible truth values that R and P must take on? Well, if R happens to be 1 as well, meaning if R is true, then P must be true. P has to be true, right? And that's exactly what this question is stating here. To get an A in this class, it is necessary for you to get an A on the final. And to get an A on the final, right, for this to happen, for the conclusion to happen, R must have happened. And R over here is that to get an A in this class. All right. Let's look at part D here. Part D here is you get an A on the final, but you don't do every exercise in this book. Nevertheless, you get an A in this class. So you get an A on the final, which is represented by, you get an A on the final, which is P. You don't do every exercise in this book, which is not Q. And then finally you get an A in this class. Nevertheless, you get an A in this class, which is R. So this is a classic example, a simple example of a conjunction being applied across all the three all the three propositional variables. So I have P and not Q and R. Okay, and then finally, if I look at part E here, part E is getting an A on the final and doing every exercise in the book is sufficient for getting an A in this class. So if this hypothesis happens, if this hypothesis actually happens, then the resultant is you would end up getting an A in the class. So getting an A on the final, which is P, and doing every exercise in this book, which is Q. If you do this, then you get an A in this class. You get an A in this class, which is R. Okay, this is part E. And finally, part F here is you will get an A in this class if and only if you either do every exercise in this book or you get an A on the final. So again, when I see the word if and only if, it implies the bidirectional operator, which is this symbol over here, and you will get an A in this class, which is R, bidirectional operator with the if you either do every exercise in this book, which is Q, or you get an A on the final, which is P. Okay, so again, all we're doing in this question is we're taking some of this unstructured text here, and we are applying propositional logic to write them out. And I think this is really powerful. Just think about this. I mean, there's the entire we have entire set of text out there, right? And as humans, we keep on producing so much of text. But now, with using propositional logic, we have the ability, if not to capture every single text out there, but we have an ability to capture most text by writing it in a simple propositional logic, and then use this logic and put it in a computer and create an algorithm and perform some analysis to see which facts are true, which facts are not true, and perform some more inferences.